Hello everyone, I hope you have a great day. Today let's check out the Leetcode problem, which is called the longest substring without repeating characters. This is an absolute classic, one of my favorite interview questions. Not only it is very versatile, but not too hard and checks a lot of the boxes. Alright, let's take a look at the problem statement first. Given a string s, we have to find the length of the longest substring without repeating characters. Before we go into the details of this specific problem, let's clarify what substring means first. For example, a substring can be an empty string in our string, or it can be one character in the string, or it can be multiple characters in the string. But what it cannot be is a non-continuous sequence of characters in the string. What I mean by this is, for example, you can't take AB and BC at the same time because there are two characters that were left out of this substring, and this is a problem. The first example is ABC, ABC, BB, and the output will be 3. For example, one possible solution could be ABC or BCA or CAB or another ABC. It doesn't really matter which one we take because all of these substrings length will be 3. But how can we find these substrings? At first, let's try to come up with a brute force approach. We can try to select longer and longer substrings starting from the first A. For example, the first substring is only A, and then the next substring is AB, and then ABC, and ABCA. Now we see that in the ABCA substring, there is a duplication because there are two A's. The next question we have to ask is, do we want to continue with the next substrings? It doesn't really make sense because this substring already has a duplication in it. It would make all the other substring containing this substring invalid. What is the next intuitive step? We can start from B. Let's take B, then BC, BCA, BCAB, and we found the duplication again. We already know that we don't want to go forward because all of the substrings will be invalid. So we start from C, CA, CAB, CABC, and we found the duplication again. So this is the pattern that we are looking for. I hope you kind of get the gist of it. What is the time complexity of this? It is going to take big O of n squared time to iterate through the whole string and find all the possible substrings. And the reason is, once again, we take one character, we start every time from this, and increase the length of the substring every time. And then, once we finished, we take the next character we start from, and then increase the length of the substrings every time. This is great, but this doesn't include checking for duplications in the substrings. How can we do that? There are multiple different ways of checking duplications in a substring. For example, we could use a set, or a map, or an array. In case of a set, how do we want to check for duplications? We will iterate through the string, taking it character by character. We take C, we check if it's already in the set, it isn't, so we can put it in. Then we take A, it's not in the set yet, so we can put it in. Then we take B, it's not in the set, we can put it in. But once we get to this C, this is already in the set, right? So we know that there is a duplication. The approach is very similar to the map. We take C, we put C in it with the occurrence of 1, and we take A, we put A in it with the occurrence of 1, B with the occurrence of 1. And then we see that there is a C already in it with the occurrence of 1, so there is a duplication. Arrays are a lot less flexible because they can only store a predefined number of items, right? So for example, in this case, we can store 26 lowercase English characters in this array. And when we iterate through this string, then we take C first and we mark it as 1, as it has a 1 C character in the string. Then we take A, we mark it as 1, B, mark it as 1, and when we get to C, then we will see that there is already one C in this array. We know that there is a duplication. Checking for duplications in a string is a pretty straightforward thing to do, and the time complexity of this is going to be linear because we only have to iterate through the string once. But this also involves space complexity because we have to store this data somewhere. So if we chose to only work with lowercase English characters, then we know that there can be 26 possible characters, and in this case the space complexity is going to be the minimum of our chosen alphabet and the input string. Our alphabet has 26 possible characters, and our string is the length of 8. This doesn't mean that it has 8 different characters in it, but we only care about the length at first. So this approach is going to yield us a big O of nth cube algorithm, which isn't very effective, right? So we have to find another way. Next, let's try to use a technique which is called sliding window. You can use this by starting from the beginning of the string. You select an arbitrary string, and then if you want to adjust the beginning and the end, you can do this by increasing the length or decreasing the length. And this way, you can go forward in the string and basically slide this window all the way to the end of the string. And the window doesn't necessarily have to be the same length all the time, but it can be. What if we start from the first character and go until we find the duplication? And then when we found the duplication, then we can decide where do we want to continue from. So in this case, let's continue from after the first occurrence of the duplication, which is going to be B. We have these 3 characters in the substring already, so let's increase the length of the substring. In this case, we found another duplication, and then we continue the substring from the character after the duplication. We take CAB, and then we increase the length of the substring. And then we found another duplication. So let's continue from the character after the first occurrence. We start from A. We have ABC in the substring, we increase the length of the substring by 1, and then there will be a duplication. But in this case, the duplication is not in the beginning of the substring, but in the middle. So it doesn't matter, we want to continue after the first occurrence of the duplication. So we start from C. We have CB in the substring, and then we increase the length of the substring by 1. There is duplication of B. So we start from B. We have B only in the substring, and then we finish the algorithm. But this is great, we cut a lot of corners and there was no repetition in this. But how do we know what is the longest substring? So whenever we find the duplication, we can actually store the length of the valid substring up until the point we found the duplication. In the first case, if we start from ABC, we know that this is length of 3, and then the next one is BCA with length of 3, CAB with length of 3, and in each case we can decide whether we want to replace the already existing longest substring or just simply ignore it. The time complexity for this logic will be big O of n because we only have to iterate through the string once and we only touch each character once. The other examples can be solved based on the same logic. Example 2 has 5 B's in it. We can take the first B, start from there, and then increase the length of the substring, but we notice that there is a duplication. So in this case, we start from the character after the duplication. We note that there was a substring with a length of 1, and then we continue from this B. We take the next B, there is a new duplication. We start from after the duplication, there is 1 character. We take the next B and increase the length of the substring. So this is the logic that we are going to use here. What about the third example? In the third example, we start with P, then PW, PWW, and we notice that there is a duplication because there are 2 W's. So we start the next substring from after the duplication, and we also have to note that there was a substring with a length of 2. We start from W, WK, WKE, wkew, and we know that there is a duplication. And also we have to know that there was a substring with a length of 3. So we start the next substring from after the duplication. We have kew. In this case, we are at the very end of the algorithm. So we have to note that there is an actual substring with the length of 3, which is going to be kew. We haven't talked about what kind of data structure we're going to use to store these substrings so far. So it can be either a set or a map or an array. It doesn't really matter. It's up to your implementation. Personally, I'm going to use a set for this. So let's take a look at the code. Alright, first of all, we need to initialize the result to 0 and create a new hash set to store our characters in. Let's do that. Then the most important part, where are we going to start the window from and how it is going to move towards the end? At first, let's try to define both left and right to 0. And we're gonna move the right pointer to the right until we find the duplication. Then, if we found it, we have to move the left pointer to the first occurrence of this duplication. So during this, we also are going to remove every element from this set that's outside of our new window. So what we're gonna do here is take the character, and then iterate until we find the first occurrence of the duplication. We start removing the elements that were removed by moving the left. And then we just increase the left pointer. And after that, we can add this new element into our hash set and calculate the length of this new substring. And after that, we only have to return the result. I hope this was useful. If you liked the video, please like and subscribe, or just leave a comment with your suggestion. Thank you, bye bye.